Today we're looking at Unit 3, Linear Functions on the Algebra 2 Semester Exam Review. And the first part of that unit is that we were finding the inverse of some functions. And remember that the inverse means that we need to switch the x and the y values. And then we need to solve for y. So as we take a look at this first problem here, y equals x plus 2 divided by 7, our first step is that we're going to switch the x and the y. X is going to go where y went, y is going to go where x went, and nothing else is going to change. The plus 2 divided by 7 is going to remain where it is. And what we need to do is we need to solve for y at this point. And the way that we can do that here, since it's y plus 2 divided by 7, is we can multiply the right side of the equation by 7, and we can multiply the left side of the equation. And now what happens is that the 7's cancel out over here, and we're left with 7x equals y plus 2. Well, once again, with inverses, what we're doing is we switch the x and the y, and then we solve for y. So our next step, and our last step, in fact, in this problem, is we're going to subtract 2 from both sides, and we get 7x minus 2 equals y, which is our inverse. In this notation here, f to the negative 1x means the inverse. Let's try another one. There's f of x. So now we have this in function notation. The first thing that we want to do is, instead of writing f of x, let's rewrite f of x as y. And in fact, let's just write down the whole problem again. Y equals 3/4 x plus 1. We need to switch the x and the y to find the inverse. Once again, x is going to go where y went, y is going where x went. Nothing else changes. So we get x equals 3/4 y plus 1. Now be careful on this one, because that fraction sometimes confuses students, but I hope that we can help you here with this video. Our first step is, let's subtract 1 from both sides. And we have x minus 1. But over here on the right side, we still have 3/4 times y. And I'm going to do this process in 2 steps. Some teachers may do it in 1, but it's 3/4 times y. And instead of dividing everything by 3/4, what I'm going to recommend is we do the same kind of thing that we did in problem number 1, where we multiply this side by 4, multiply the right side of the equation by 4, and then we're going to multiply the left side of the equation by 4. When we multiply the left side by 4, we have to multiply the entire value by 4. So we have 4 times x minus 1. But what happens over here on the right side of the equation is that the 4's canceled out, and we're still left with 3y. Number fraction, so that's good for some of us. But now let's distribute. We get 4x minus 4 equals 3y. And remember what we're trying to do. We're trying to solve for y. This is 3 times y. So we're going to undo that operation by dividing both sides by 3. And then our inverse will be 4x minus 4 divided by 3 equals 1. Again, this is our inverse. One more practice of this, and hopefully you will have tried this on your own before you watch this. But g of x. Well, g of x is still an appropriate way to write the problem. It just means y. So we're going to rewrite the problem so that we have g of x in its form of y. When we're solving these, or determining the inverse of these, we have to switch the x and the y. X is going to go where y went, y is going where x went, and we end up with x equals 5y minus 3. Again, our goal is to solve for y. So we're going to move that 3 over to the other side by adding 3. We get x plus 3 equals 5y. And we're close to finishing now because we want to end up with y equals. So right now it's 5y equals. So to undo 5 times y, we will divide by 5. And we end up with our inverse of x plus 3 divided by 5 equals y. There's our inverse. Now also in this unit, what we did is we did some graphing. So as we look at problem number 2, the first part of number 2 says graph the line f of x equals 2x minus 6 on the grid provided. Well, let me remind you that this is y equals 2x minus 6, and we want to identify our y-intercept, which is the constant in this problem, which is negative 6, and our slope is the coefficient in front of the x. And remember also that slope is rise over run, so it may be helpful for a couple people if we write that as 2 over 1. To graph, we're going to come down here to negative 6. And we're going to put a value on negative 6. Our slope is 2 over 1. Up 2, to the right 1. Rise 2, run 1. Rise 2, run 1. We could also go down 2 to the left 1. Down 2 to the left 1. But here, in fact, I'm going to continue the pattern up 2 to the right 1, up 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 to the right 1. And I'm going to try to use my line on the smartboard, which may or may not work for me. And it's pretty good. Until that happens. Let's see if I can scoot it back over. And there's our arrow down there. Point. It needs to be over here. There we go. Sorry about that. So now we've got our line graphed. Well, the next part says find the inverse of this line. We already have it written in the proper form. It says y equals 2x minus 6. And once again, what we're going to do when we find the inverse is we're going to switch the x and the y. So x goes where y goes where x was, and we eventually need to solve for x. Sorry, we need to solve for y. So we're going to have to move the 6 away from the y. So let's add 6 to both sides. And we get x plus 6 equals 2y. But again, we're trying to identify our inverse here. So it's 2 times y. We're going to divide both sides by 2. And in this particular case, because we're going to have to graph, I'm going to separate it out. I'm going to divide x by 2 and 6 by 2 as well. Then we have it y equals here, and it's x divided by 2, which, by the way, is 1x over 2. And 6 divided by 2 is 3. Now, the reason that I did that is because we're going to have to identify, well, what is the y-intercept of this line? And what is the slope of this line? And again, the y-intercept of this line is the constant value, which is 3. And our slope, now that we put the 1 in there, is 1/2. And part B here says that we want to graph the answer from part A and label it f of x. So I'll go back here and I'll put f of x in here, and then when we label our inverse, it's going to be f to the negative 1 of x. There's that symbol that we saw back on problem 1a. b equals 3. And then our slope is 1/2. Up 1 to the right 2, 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 up 1 to the right 2. We could also go down 1 to the left 2, 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 down 1 to the left 2. And I think I'm going to try to draw this freehand here so that we don't have issues. Ask your teacher for a ruler. And there's our f inverse. So what line do the inverses reflect over? Well, the line that the inverses reflect over is y equals x. And a couple things you can do. You could say that this is y equals x plus 0, which I think is harder than it needs to be, because then you'd have to say that m equals 1 over 1 and b equals 0. But depending on your teacher, what you may have talked about is the fact that y equals x is the line that goes from the bottom left-hand corner of the graph to the upper right-hand corner of the graph and through the origin. Right there. I'm a little bit off on there because, again, it has to go through the bottom left to the upper right and through the origin. But that's the line y equals x. If you don't like what I just said, then graph b equals 0 and then the slope of 1 over 1. Also in this unit, we talked about the average rate of change. And as we flip our paper over, here it says, use the table to find the average rate of change over the given interval. Well, first of all, what we need to do is we need to identify the fact that in this particular problem, 1 and 16 go together. And as we look at our table also, we see 4, -5. So we went back and looked at those because it says x is between 1 and 4. And what we have to do when we're finding the average rate of change is we're using our slope formula. And the slope formula, as a reminder, is y2 minus y1 over x2 minus x1. And it should be more specific, y2 minus y1 divided by x2 minus x1. And we can label this in our problem. Here's x sub 1 and here's y sub 1. Here's x sub 2 and there's y sub 2. And once we have that information, we can go back and put that into our formula to find the average rate of change. -5 minus 16 divided by 4 minus 1. And -5 minus 16 is -21. 4 minus 1 is 3. And when we simplify that value, we end up with -7. So there's some other points here that we could use in this problem as we look back at our table. This time we're going to look at the value when x is 3 and when x is 5. And when x is 3, we have a point of 3, 7. And when x is 5, we have a point of 5, -8. And once again, if we look at this, this is x sub 1 and this is y sub 1. Here's x sub 2 and y sub 2. And we're going to put this back into our equation. It's going to be -8 minus 7 divided by 5 minus 3. And -8 minus 7 is -15. And 5 minus 3 is 2. And we can't do anything else to that. There is our average rate of change, which also happens to be our slope. So finally down here in part C, the question says, is this a linear function? The answer is no, because the average rate of change, and remember we abbreviated it ARC, average rate of change. The average rate of change, I'm not sure of the English there, is or are different values. If they were the same, then we would have a linear function, but they are not. This is probably coming back to you. As we look at another one, it says, given the function f of x equals x squared plus 5x minus 11, find the average rate of change for the interval where x is in between -5 and 3. Show all work. Hint, let's use our calculator to help us save a little bit of time. So we pull up the calculator, and where we're going to go is we're going to go to y equals, and we're going to type in our function here of x squared plus 5x minus 11. What we want to look at is we want to look at the table. So we're going to go to second and graph, which gets us up to the table feature here. And it says, find the average rate of change for the interval between -5, where x is between -5 and 3. So we need to scroll back here on our calculator for a minute until we see -5. And -5, beside it, you see -11. So let's write that down. We've got -5, 11 for one of our points. And then as we go back to our calculator and we look at the screen, we can still see 3 on here, and 3 has its y value of 13. So 3, 13, and once again, once we have that information, we can use it to fill in our formula there, which hopefully you went and wrote down a few minutes ago if you needed to. This is going to be 13 minus 11 divided by 3 minus -5. 13 minus 11 is 2, and 3 minus a -5, remember double negative gives us a positive. 3 plus 5 is 8. And if we need to here, we can simplify, but I need to go back and look at my problem here for a minute, because it seems that what's on my paper in front of me and what my work here, I didn't, I have right for my work, but I want to go back here and look. I think I wrote down something wrong, and I did. It's 5 -11, so I need to go back and correct that. Sorry about that. Hopefully you're writing in pencil so you can erase. But it's 5 -11. I did the process right. I just didn't write down that sign, and that caused the problem. So try again. 13 minus -11, and 3 minus a -5. So not only do we have the double negative on the bottom, like we just were working with, but we also have a double negative on the top. And 13 plus 11 is 24, and 3 plus 5 is 8, and 24 divided by 8 is 3. And that's our average rate of change. So, note to you, as well as myself, is make sure that you are looking at the calculator and writing down what you see. Finally, let's look at the average rate of change with respect to the graph. And by the way, you can always go back and use a corresponding point. But ultimately what the average rate of change here is its slope. So if we look at the value here of 1, when x is 1, our y value is 5. And when we look at our x value of 4, what we see here is that 4 corresponds to that point of 4. And what we can do, because average rate of change is rise over run, we can kind of draw a picture. We went down 1, and we went to the right 3 spaces, so our average rate of change is 1/3, and in fact we went down 1, so it's negative 1/3. Let's try that again. Here with this other point, I'm going to erase the green. And let's look at our values for 3. 3 has a corresponding y point of 1, and 7 has a corresponding y point of 3. And again, what we can do, we're going to rise to get to that other point, and we're going to run. So we rose 1, 2, and we ran 1, 2, 3, 4 to the right. Rise 2, run 4, and we can simplify 2/4 to be 1/2.